Okay, thank you very much, ladies and gentlemen. I'd like to end the day with a short presentation on how you can use workload automation to deliver as a SaaS platform. So I'm going to look at a number of areas that give you challenges about operating in a SaaS environment, in a dynamic environment. So normally we're talking about workload automation as a data center discipline with a workload manager or managers delivering workload automation to a server farm, an IT real estate, on-premise, locally managed. Now, over the last 10, 15 years, that's been moved maybe to an outsourced model, but it's still on-premise hardware. What I want to do over the next 30 to 40 minutes, I do appreciate that I'm the only thing standing between you guys and the bar, so I'll try and keep it short and sweet, but I want to show you how you can actually very easily take any one of CA's workload engines and actually use that to deliver workload automation either to the cloud or from the cloud. So, SaaS and workload automation. As I mentioned earlier, in simple terms, software as a service, cloud or whatever, there's no such thing as the cloud. It's just other people's hardware and a different way of pricing, consumption-based pricing. But from a technology perspective, there are a number of challenges when you're looking about providing workload automation either to or from the cloud. And typically, cloud-based services differ from the traditional IT disciplines in the fact that they're multi-tenant, they're scalable. So when you talk about Salesforce.com, you're using shared hardware, shared infrastructure. You're benefiting from the economy of scale that these cloud service providers have. So how can we do that with a workload automation solution that was never actually designed to work in other than an on-premise environment serving one customer? So how do we twist workload automation and align it to cloud principles? Well, the first thing we need to do, and this is not a technical argument, it's a purely commercial argument. We need to be able to have a pricing model that is some way based on your consumption of that workload services. Whether it's how many jobs you run, how many jobs are defined within your environment, or some combination of both. That's a commercial decision that CA and other workload vendors can make on how we set those pricing marks. But we have to be able to do that. So it's again a purely technical. Scalable. Well, we need to be able to scale to support the larger customers as well as the smaller customers. It's upward scalable and downward scalable. Now we know that our workload automation solutions can scale to many millions of jobs, many millions of job executions per day. We're doing this every day with our current customers. But what about downwardly scalable? A small customer who's only got half a dozen servers, 200 or 300 jobs that run every day. Not very large, but very important to that business. It's equally important to that business that those 500 or 600 jobs that they might have defined run accurately and on time, because otherwise their business suffers. Multi-tenant. And herein lies the slight difference between workload automation as we traditionally know it and what we see with the more modern cloud service offerings. But with all our workload solutions using role-based access control, you can isolate the jobs run by one customer from the jobs run by another customer. So whilst we're not multi-tenant in the true sense of the word, we have separation of access to the data, if not physical separation of the data itself. Web-based. Well, yes. Our major platforms, with the exception of the ESP edition on the mainframe, are now fully web-featured. AutoSys, D-Series, CA7 all have web services. Also web front ends as well as web services. So it's equally possible to use these and have customers access their job and their workload information over a web-based interface. And we will be completing the design and development of the ESP web interface in the not too distant future. Externally hosted. So you don't want these things on premises. There's no point in trying to offer a software as a service solution if all you're doing is dumping a workload server on a customer's premises and managing it remotely. That's called outsourcing. It's not the same. So we want to be able to offer a service with a workload management server somewhere in a data center and have the IT infrastructure of multiple customers connecting safely, securely to that infrastructure in order that the workload of all the customers can be run appropriately. So this is where the main challenge lies within any cloud-based offering of workload automation. And in this, I'm not talking just about having a workload management engine in the cloud providing services to multiple customers, but what about customers themselves who have servers on AWS or whichever cloud host that they've chosen? Cloud environments are by their very nature dynamic. So you're not even sure when you want to schedule work to a system, is it up? Is it available? And when I've run the work on that system, should I be able to tear it down? Because cloud-based services are consumptive-based pricing. So having a server on Amazon sat idly doing nothing is not really a good use of your money. So, to mention, typically we had our workload manager scheduling to our workload our IT infrastructure and administered all locally. No challenges there. That's our vanilla product as we all see it today. And we've seen it like that for years. Maybe, as I said, for the last 10 or 15 years, we've allowed external companies to manage our workload infrastructure for us. Outsourcing, outtasking, run and operate, call it what you will. Essentially, it's outsourcing. So how do we move from that model to something that is more a SaaS platform? So firstly, we can remove all the administration from the local site so that we have a service-based model and the end customer is just a consumer of the service. And with the web-based interfaces, these can be administrators of the solution from a service provider, or they can be customers accessing through the web their own workflows, monitoring, defining, amending their own workflows. So that we can do today. And likewise, we can, and we do support, all our workload agents run on the major cloud platforms. So if you have servers provided by Azure, Google, Rackspace, etc., we can have agents on there. So all of that is achievable now, especially since with these servers, the cloud providers have solved the network challenges for us. But that's just one aspect of integrating with the SaaS environment. I've not touched anywhere yet on how you can actually have the workload manager and actually have workload automation as a SaaS offering offered to customers on a consumptive-based model. So how do we move that workload manager to the cloud? Well, technically, it's not that difficult. We have the internet, runs over TCP/IP. In essence, it's not that different from our local area network. Might be a bit slower, but we're not shifting huge amounts of data around generally when we're talking about workload automation. It's just start a job, has the job completed, get the job status, start the next job, read a spool file. There's not a lot of data passing over those networks. The challenge arises when we start thinking about how do we service multiple customers in that environment. So we've moved our workload manager into some sort of data center. We'll call it the cloud. I think it's a much abused term because the workload manager itself will probably be running and servicing customers 24/7. And you access it over the web as you did before. The IP address is different, the domain might be different, the URL looks a little different, but it's no different in principle. And you can connect using the service providers, Amazon, Google, Microsoft, etc., provide you the necessary private connectivity to your workload manager that's now in the cloud. But again, we've not talked at all about multi-tenancy. This is all a journey. We're getting closer now to where we want to be. Because what we can't do, we've got to be careful if we have customer A, customer B, and customer C, if we're a workload automation SaaS platform provider, how do we ensure that workload defined for customer A can't run on customer B? Customer B can't see customer A's data, etc. Well, a couple of things we can do. First off, we can lock that workload manager down so that when you access that workload manager, be it CA7, AutoSys, D-Series, you can only see the workload artifacts that are defined for you. And typically, we would use strong naming conventions to ensure that customer A only has jobs that start with A, for example, and resources and all the other job artifacts. You would enforce strong exclusive naming conventions. And that helps you secure the user interface so that users from different customers can't interact and can't affect the workload of others. But it's a whole different ballgame when we're looking at network traffic, because in some way, shape or form, customer A, B and C, all their servers are connected somehow to that workload manager. So we need to be able to ensure that there can absolutely be no possibility of any network traffic going between different subscribers to our service. And there's a number of ways we can achieve this. And I just want to highlight one simple way that has already been effectively used in a service provider in Europe to achieve exactly this. And it was the light bulb moment that I had a couple of years ago. Rather than using the VPN or just using the VPN that is provided by your SaaS platform provider, do something different. The VPN provided by your Microsoft, by your Google, your Amazon, is designed to be site to site. But it doesn't actually necessarily enforce cross-site, because you might have a customer with multiple sites. So unless you're prepared to spend an awful lot of money on an awful lot of firewall appliances and then spend the necessary time and effort keeping the firewall rules up to date to make sure you can have no possibility of network crosstalk, then you're going to have a few problems. So let's redesign that VPN. And what we found, after some experimentation and some research, was a piece of open source software called OpenVPN. Has anyone here heard of or used OpenVPN? Nope. You have. Good. At least one person. And what it does, it can provide a secure tunnel point to point between wherever the server is and wherever you install the OpenVPN client. So if you install the OpenVPN client here and use that IP, the OpenVPN server's IP address here, and the workload agent installed here will only be able to talk to that server. You cannot even talk between any of the other servers on your own local site, let alone anybody else's site. So you're effectively creating a big star-shaped network using OpenVPN to ensure point-to-point communications only. And the big advantage that I think that we have with OpenVPN is that it can be configured very easily to listen on port 443. So anybody in a customer, say over here, will be talking over port 443, HTTPS. It will go through any proxy, and you can always find a route to your OpenVPN server and therefore your workload manager, or in fact your workload managers, because you would probably have multiple of these set up for failover and redundancy and scalability, of course. So we have no issues hiding behind people's firewalls on the internet. You can simply drop an OpenVPN client and a workload agent on a machine, configure it to talk to the OpenVPN server, and you've got point-to-point communication for workload automation. So that secures not only the network traffic from external attack, because you're using SSL-based encrypted traffic, you've got rid of that issue of point-to-point connectivity, so you can't get data leakage between your other customers. And you can also further make sure you're secured by using certificates, so that when you deploy an agent, when a customer subscribes to your service, you deploy the OpenVPN client to them, the workload agent, and a certificate. And you can revoke that certificate at any time, so that if the customer decides not to renew their subscription, for security purposes, you could revoke their certificate, for example. Or if they suffer any security breaches themselves, you can revoke and reissue certificates to ensure that only the customers and only the clients, only the servers that you have specifically authorized to have that software installed and deployed can subscribe. So you can't have a customer deciding they're going to buy one agent's worth of service and then deploy on multiple servers here. Certificate-based authentication will totally stop that. And just as a side, OpenVPN can share its SSL port with a real web server and distinguish between incoming web traffic and incoming VPN traffic and forward the web traffic onto somewhere else. So you might actually end up as a service consumer connecting to what you think is the service provider's normal website, but over HTTPS. But under the covers, all the traffic is rerouted, so you're not actually exposing any extra IP addresses or URLs as attack vectors, surfaces from which miscreants can perhaps try and attack your service provision. And because we're using point-to-point networking, each workload client, each end node at your customers will have a unique IP address within that VPN space. So you might decide to use a 10.x space for your OpenVPN server and split it down as however you like into 254 subnets of 65,534 addresses. So this scales from a network perspective beyond anything that the actual workload engine itself is designed to support. I've not seen any real-life implementation of our workload solutions that actually schedules work to more than a few thousand agents. And I wouldn't expect that to be the case or any different in this scenario, because we're not actually changing the software. We're changing how we use the software by making sure we enforce strong naming conventions and have very strong role-based access control to ensure that users can't access workload artifacts from other subscribers to your service. But we're also making sure that the underlying network itself provides secure, isolated, point-to-point links for that workload information. So, very highly configurable, very easy to use, very scalable, and deploys a very small footprint at each of your customers' servers. So, if you have somebody who wants to subscribe to your service, it's very easy to send them a download package that contains the workload agent and the OpenVPN software client with all the necessary configuration information to form that point-to-point tunnel. And the only thing you need to deliver uniquely to each one is the certificate. So it becomes very easy for a non-technical user to actually install the workload agent, the required software on these servers, and then start having their workload delivered to them automatically from somewhere in the cloud. So again, that role-based access control is central from the user side. And the OpenVPN secures the network layer. So we're actually introducing a whole layer of network over and above what the physical network is. And so I would be recommending that you use private IP address ranges. 10.x, 172.x, not 192.168. something. You'll find your smaller customers are already using it. But there may be cases where your customers themselves are using the IP address range that you intend to use for your OpenVPN traffic. That's a problem. Solve it in a number of ways. You can have multiple servers with multiple workload servers, each with its own OpenVPN, and each with a different network IP address ranging. Or you could even install multiple instances of the OpenVPN server on a single machine. So it can serve two different non-overlapping IP address ranges, and then you just choose which of the server IP addresses that a user will connect to, and that will determine which VPN IP address that they will receive. But I say it's really about the strong naming conventions that you've got to enforce, because it's no good having your network's traffic separated if your tenants can see each other's workload. So there is an administrative overhead as a service provider in making sure you've got your role-based access control sorted. Now we have, obviously on the mainframe, ACF2, top secret, RACF, plenty of security systems that can ensure that users are kept separate from each other, or the workload artifacts of different users in different domains are kept separate. Within AutoSys and D-Series, we have the same concept. Slightly different mechanisms to achieve it, and we see these mechanisms in use today in our larger customers, because if you're, say, Apple, and you've got a huge AutoSys estate, and you've got lots of users, lots of different lines of business, they don't want to see each other's jobs. Because when you've got a workload monitoring screen, you don't want to see 50,000 jobs and try and hunt what's my own job status, or a workflow with 50,000 jobs on it. You want to get rid of that clutter, because there's only 500 that are important to you. So the use of role-based access control is increasing more and more within the workload automation space, simply to avoid the clutter and to separate out different internal lines of business. And all we're doing now is extending that concept to, if you like, external lines of business. So when you're considering deploying such a solution, you are adding an extra level of complexity. So as well as considering workload automation failover of your core service, you need to make sure your VPN is also up to the same standard. So if you have hot standby servers, you need to make sure you have an open VPN or a VPN service on that hot standby ready to kick in, and you can define your VPN client that will talk to server A by preference and fail over to server B. So all of these building blocks are there. It's just a matter of making sure you configure both the workload component and the VPN component to take advantage of them. So now let's flip for a while and think about, well, what about workload executing in the cloud? Whether it's from on-premise hardware or whether it's from a cloud-based service offering of workload automation. Well, it's no different. You've still got a TCP/IP connection between your workload manager and your cloud-based agent. Whether that is direct or whether it's over some self-provided or some service provider provisioned VPN, doesn't matter. You've got a host name or an IP address that you need to use to throw your workload at. The challenge comes when you're looking at dynamic workload environments, when you're spinning up and tearing down your AWS or your Google or your Azure services. Now, it's very simple to be able to check and have some pre-flight checks that all your servers are going to be up before you schedule workload to them. You know your workload. You know where it should be scheduled. The challenge comes, and I don't think there is an answer to this, is that when you've completed your workload, do we then spin that server down? The short answer is you don't know, because you might end up interfering and conflicting with other workflows that may be wanting to execute on that server. And you might be spinning it down as somebody else wants to spin it up. Or worse still, you might be spinning it down, another workflow said, yes, the workload is available, and starts trying to provision something onto something that's going to fall over on its knees and not be available very shortly. So this is always going to be a challenge. But I will submit to you that, generally speaking, when you're submitting workload automation or jobs in a workload way to servers, they are typically servers that are serving the business and need to be up 24/7. I haven't found many cases where that is not the case. Or it is scheduling workload to servers that have been specifically brought up to perform one business task. Whether it's big data, bringing up a Hadoop cluster in the cloud, or whether it's just bringing up a server farm of databases to do some stuff, some analytics, and then collapse it all down. At which point, you know when you've completed that you can collapse that server farm. So there isn't, I've found many cases where you've got truly dynamic workload where you're bringing servers up and you don't actually know whether you need to bring them down or not. Because people actually haven't got into that mindset yet. I don't think we've reached that threshold. People still think, yes, I need to have my servers up 24/7 because they're doing stuff and I need them to be there, or I'm bringing them up for a specific task and I know that I can bring them down. And that's the beauty of cloud. So you can bring stuff up, bring stuff down. But if you have two separate lines of business trying to access the same cloud-based resources and they're trying to bring them up and down, that's where you need to manage the potential for conflict. And if you want to do that, we're really talking about a level of process management over and above workload automation itself. It's looking at the dynamic provision and placement of the workload. And for that, we have a solution called CA Process Automation. It used to be called IT PAM. So you might want to consider, if you do run into potential for conflict, where you've got the need to dynamically provision servers and also dynamically provision the workload to those servers, that CA Process Automation might be a tool that can help you to do that. So where is the market opportunity? Why have I spent many hours of my life actually researching, developing, testing this type of solution? Well, there is an appetite, certainly within service providers, to actually be able to scale down into the small and medium enterprise. And similarly, there is the appetite within the small and medium enterprise to take the benefits of what is essentially outsourcing their workload automation infrastructure to somebody that's bigger, more scalable, benefit from that economy of scale, and concentrate their efforts on their core business. So we started to see this in Europe a couple of years ago. Certainly there was push down from the service providers because it's a very cutthroat market. And if you can start scaling down to the smaller enterprise, then, especially if you're first to market with this type of solution, you're going to get a huge advantage because everyone else is just going to be following. But also from the small business. Mike Gregoire said, every company is a software company. Now, it's less true for smaller companies, but every company is an IT company. And companies want to concentrate on their core business, but smaller companies haven't until now been able to afford outsourcing. Outsourcing has been for the larger companies. Well, this extends that concept right down to the business that only has 1 or 2 servers. You can still make sure that their jobs are run on time, every time. So that's pretty much where I wanted to be, 5:10. You've all sat very quietly and patiently through here. Do you have any questions? Oh, yes? Would you want to do that?
I don't know, I'm just asking.
The short answer is it's possible. I can't see why any of this isn't possible because you're talking about just changing configuration files and database entries on a template. But a workload manager is usually the thing that's going to be there 24/7. Yeah? And it's the things that you schedule workload to that are likely to be dynamic and brought up and torn down on demand. So whilst it's possible, whilst we could, we ought to be asking, should we? Yeah? Any more for any more? Well, thank you very much. I hope you've all enjoyed CA World and hope to see you again next year.